I now take up 7.6 inverse functions. In this section, we take a closer look at inverse functions of one variable. And to understand, we start with an economic problem. Suppose that the demand quantity D for a particular commodity that depends on the price per unit P according to this equation. D P raised to the power 1 by 3 equal to 30. And here P is obviously greater than 0. D is also greater than 0. Just understand here that we are concerned about the demand quantity D for a commodity and the price per unit P. Now, in this case, let's call this equation 1, and let's try to solve this equation for D. And when we do that, we get D equal to 30 divided by P raised to the power 1 by 3. I can write that as 30 into P raised to the power minus 1 by 3. This equation, in fact, yes, this one, this tells us directly the demand D corresponding to a given price P. So if suppose P is 27, if P is 27, D will be equal to 30 divided by 27 raised to the power 1 by 3. Now we know that 27 raised to the power 1 by 3 is 3. So that means D is equal to 10, 30 divided by 3. So clearly D is a function of P, and that means I can write this. D is equal to f of P. The demand D, the demand quantity D for a particular commodity, it is a function of the price per unit P. Okay, and here f of P is equal to 30 divided by P raised to the power 1 by 3. But the problem here is that if I look at this whole thing from the firm's point of view, it may be more natural to treat output as something that the firm can choose. And then we consider the resulting price. What does that mean? That means from equation 1, which is this equation, I write that again. From this equation, I try to take out P. And when I say I try to take out P, I can write that as P raised to the power 1 by 3 equal to 30 divided by D. And here I can take P raised to the power 1 by 3 raised to the power 3 equal to 30 by D raised to the power 3. That means P is equal to 27,000 divided by D cubed. Or in other words, I can write P to be equal to 27,000 multiplied by D raised to the power minus 3. Now if I look at this equation, this in fact gives us directly the price per unit P corresponding to a given output D. So now in this case, if I suppose that D is 10, then if D is 10, then what is P? P is equal to 27,000 divided by 10 raised to the power 3. That means P is 27. So in this case, P is a function of D. Now the function can be written as P is equal to G of D, where G of D is equal to 27,000 divided by D cubed. So in this case, we see that the two variables, the demand quantity D and the price per unit P, both of these variables are related in such a manner that allows each of them to be a function of the other. And in this case, I can write that these two functions, f of p equal to 30 multiplied by p raised to the power minus 1 by 3, and this function g of d equal to 27,000 multiplied by d raised to the power minus 3, I can say that these two functions are inverses of each other. So f of p and g of d, these are called inverses of each other. And we can also say that the function f is the inverse of g, and g is the inverse of f.